So hi, good evening everyone. So I pasted the previous Anthem revision session, so you can watch two link like that will be like great help for your Anthem revisions, like Anthem preparation. And the like question pattern will be like there will be five MCQ questions, and there will be 15 3 marks questions. So it will be most of the question will be the NAT, right? So I would suggest like solve mock questions and solve all the PA and GA questions and solve previous like POI questions and understand the concept how to solve the question. That will be sufficient. So I will strongly recommend watch to previous anthem session. That will be like very good for your anthem preparation. Rahul, you can start.
Yes, sir. Yes, sir. I'll begin. I'll share my screen. Chaitanya is of course you're the second in charge for this one.
Rahul, how many terms this course has been offered till now?
This is probably the third term because in my time I had only one PYQ. I think so. Uh,
So,
Shubhendu
Ah,
sir,
yes, it is third term.
third
Yes.
term, na? Huh, okay.
so if possible, can you please avoid those terms, discussion on those terms which has already been discussed? Like if दो लिंक शेयर कर दिए ना इन्होंने जो सुवेंदु सर ने तो
Hmm.
उसमें उसमें जो डिस्कस हो गया है शायद उसको ना करें अच्छा रहेगा
अरे मुझे थोड़ी पता है कि उसमें क्या था. मेरा
It's
मेरा
like
टर्म वाला शायद था,
Rahul.
but that's been 8 months.
I think most of the people did not understand this, so better to talk English. It's
Ah, yeah,
recorded.
yeah, yeah. Yeah.
या
So the thing is, they'll. I'm not sure what's the content of that. It's been a long time for my session as well. Today's plan is just going through the PYQ of January term, the end term PYQ, and that should probably cover up most of the questions that might that would probably come in. So that should be fine, I think.
गो अहेड कुछ तो सीखने को मिलेगा
Now let's go ahead for this one. So this is the first question. Let me check if it's the right subject. I believe so. CST, yeah. My screen is visible, right?
Yes.
Yeah, okay. So in a 4-bit system, the ones complement of the binary number uh, 0001 is 1110. So what happens in ones complement? We just flip the bits. 1 becomes 0, 0 becomes 1. So first three zeros and then 1, that becomes first three ones and then 0. Correct? This is a straightforward one, I guess. So for the second one, an asynchronous counter uses a common clock signal to trigger all flip-flops, while a synchronous counter uses the output of each flip-flop to trigger the next flip-flop. Is it true or false? And if it is false, why is it false? Who will tell me?
false because reverse it is written in reverse order
Only the opposite thing is written. The word synchronous obviously means it's going to be in some kind of sync with something. So that obviously means that it has to be a all the flip flops are going to be triggered by the common clock itself. So it's written reverse, obviously, and if it is an asynchronous one, the output of one goes as the input of the second one as the clock. So it's the opposite one, so you'll have to deal with that. So it's obviously false. Moving on to the third one, in a in a system with 65 unique states, five flip flops are sufficient to represent all the states. Is it true or false? It is false. But why is it false? Because in a particular okay, we need 65 unique states. So think of it in this way: how many bits do you need to represent 65 unique states?
7 bit
7. 2 power 5 is 32. 2 power 6, 64. 7. Yeah, we need 7 bits. So in order to get 7 bits of representation, 5 flip flops will not be enough. Correct. You need 7 flip flops. Is that okay?
yeah
Because yeah. So it's obviously going to be false. For 5 flip flops, you'll only get 32 unique states. In a decoder, at any point, exactly one of the outputs is 0, and the rest of it is 1. It doesn't make sense. I mean, even if it's an encoder, even if it's a decoder, one is supposed to be 1, and the rest of it is supposed to be 0. This is the opposite statement written. So this must be very. It's a very straightforward question. No explanation, I believe. Okay, Moore's law. Moore's law computer has 2 million today, then it will have 64 million in 8 years. So what is Moore's law? Moore's law states that it doubles every 4 years, I think, if I remember correctly. If someone wants to
2 years.
correct me, please say.
Doubles every 2 years.
It what?
Once.
It doubles every
2 years.
2 years, right? Hmm. So, so if it is doubling every 2 years, after 2 years, 2 million will become 4. After 4, it will be 8. After 6, it will be 16. And after 8, it will be 32. So it's not going to be 64 million transistors. It's going to be 32 million transistors. In 10 years, it will be 64. So that's the other way around. All right.
One conceptual question can I ask here?
Hmm.
Is it true even right now? Because I thought uh, the number of transistor is now stagnated in most of the computers.
Technical details, I mean, we'll have to look into it. But
Go,
just by the
go ahead.
concept, that's how it is.
You can avoid the discussion.
Rahul, I have a different question. So here,
Yeah.
hello.
Yeah,
Yeah.
yeah.
So
Please,
yeah, in how many years? As long as there is even, that is okay. But you're making sure that it will not come as a odd number of years, right? Say what will be
no,
happen
no,
in
it's
3
definitely not
years
going to come as
or
an odd
5 years?
number.
Okay, thank you.
I don't think so. I mean, if it is,
Yeah, Rajesh, so it won't be odd number of years, so it will be like even number of years. Don't worry.
okay. Even number
Thank you.
confirmed, right, Sunil sir?
Yes, it will be only even number, not
Okay, perfect. Okay, moving on. Uh, in question, I think this is the next one. Yeah, in question 101, what do we have? We have considered the Boolean operator. There's something with the following properties. X operator X is X. X operator, what is it? X bar. 1 minute. Yeah, X operator X bar is 1. X operator 1 is 1. X operator 0 is X. Then X operator Y equal to what? So you would have to think, say Y is a random sort of a variable. It could be anything. So you have to look at it. I mean, one way of doing this is just go ahead with the options. Like, first of all, try or. So X or X, what is it? It's X. Fine, satisfied. X or X bar, 1, satisfied. Either of them would be 1 regardless. So X some or 1 is 1. X or 0 is X, because 0 is not going to affect it in any way. So it depends on what X is. So that is going to be the output. If it's 1, it'll be 1. If it's 0, it'll be 0. So this is the way you can do it. And if you want to do it using XOR, or this is X XNOR, you would have to think of it that way. X XOR X is what? Say it's 0 0. XOR will give you what? 0. So for this one, it is true. But what if it is 1 1? Sorry, what if X is 1? So 1 XOR 1 is what? 1 XOR 1 is 0. So which is not X. So there XOR fails. Same thing you can try with X XNOR. It will fail for one of the cases. It will definitely fail for this one itself, I think. So that's how to solve this one.
So we are checking in the reverse order from option. Is there any way to like approach or from forward approach?
Forward you can try, but it's going to be a lot more complicated, I think. I mean, I did it in the reverse order. It's a lot less chaotic. When you have options, just go ahead with it.
Yeah, in reverse order, it's fine to do.
Just do it. As long as you have an option, just do it.
and best option is you can make a truth table with the help of
Make a
whatever
truth
the,
table.
that will be good.
So that's an easy one. Okay, for the this diagram, what are they asking? There's some stuff. The above diagram can be represented with two inputs or with two input XNOR with XY as input. So see, the trick here is two input XNOR, two input XOR. There will be some XOR XNOR stuff with YZ XY or something as input. So the thing is, what you need is basically to find F, right? and YZ are select lines. So if you find F, you'll understand what is the representation of that, and you'll see the expressions over there. So, Shubhendu sir, do you have a drawing board or something? I'll see if I can do it on Excel.
No,
Or if
yeah,
I,
it is like maybe you can explain like that. See, what will be the 4:1 multiplexers like
hmm.
so it will be like
What will be
y
the
bar z.
output? What will be F basically?
Yeah, yeah. Well, like y bar z bar, then x,
Hmm.
then y bar z bar, the x. Sorry, then 0 1, right? So
Hmm.
y bar z I1,
Hmm.
then 1 zeros, right? So it will be y z bar I3.
Hmm.
So I3 is x bar, right? So you can in that way you can solve. Just write
Hmm.
in the maybe.
Basically, take two x's, something
Yeah,
like that.
yeah,
So
correct.
take two x's. Say when x is zero, I0, I1 is zero, I3, I2 is obviously one. So select lines will be 0 0 0 1 1 1 0 1 1. So when it is 0 0, you're taking this as 0. So like that, create the expression, and you'll get something that Chaitanya has pasted in the chat. Now, when you will try to minimize it, you'll get an expression which is a representation of x and y. Z will be eliminated, and that will be a XOR expression. So you will get something like xy bar plus x bar y. I think this is what I had got. So if you try to minimize this one, you'll get xy bar plus x bar y. So that will be, yeah. So in the expression that he has got, you will if you try to take z bar common and z common in the other one, so you will get z plus z bar into x or y. So you'll get something like Chaitanya, write the minimized one if you have got it. Just paste it there. Yeah. In the meantime,
I
let's.
I guess the best approach would be just directly create a Carnot map.
Uh,
XYZ.
Carnot map. You can
XYZ
create a Carnot
Carnot
map.
map
Yeah,
separately.
yeah. I mean, once you have the expression, create a Carnot map and minimize it. But just find the expression first. That's it.
No, so that's what I'm saying. So even without creating the expression,
Hmm.
you can directly create the Carnot map. So in one side it will be only X and another side Y
It will
and
be
Z.
YZ. Yeah, yeah.
Something like that.
That would also help.
Yeah.
So yeah, I tend
Rahul,
to write the
one second.
expression first though. Yeah, Manish.
Yeah. So we have to first write truth table, right?
Not truth table. Just find F. If you want to do it uh,
Yeah.
in a way, then find
To
F.
get the expression of f, first of all, we
No,
have to write truth table, right?
you don't need a truth table. But yeah, you can make a truth table. Yeah, make a truth table and write the expression. Yes, yes.
And any shorter approach.
No, there are no shorter approach. Once you make the truth table, you get the expression, or you can directly put that in the Carnot map and get the minimized expression, like Rajesh said over there. So that's the only way to do it. There's no other way. So this will be the 4 by 1 multiplexer. You just minimize it and you'll get the answer with x and y as the variables in the expression. Z will be eliminated. So for this one, the given truth table has to be realized with D flip-flop as shown below. So 0 0 is 1, 0 1 is 0, 1 0 is 1, and 1 1 is Q and bar. So this is AB going. So the third input to this logic is basically Q, right? Or Q previous, or whatever you can say, Qn in a particular state. So what will be the expression of this logic such that you are giving it a putting it into D? How will you understand? You'll have to see that if AB is 0, then Qn plus 1 is 1. So what you can do, just write the expressions for it, for which it could be 1 or something. So how did we do it? We ignored the zeros of the output, correct? While we were doing it to find an expression, for to find the minimized expression or something, we were only taking ones. So for 1, what will it be? It's a bar b bar into q n plus 1, correct? And for qn bar, we don't know what qn is. So qn bar might as well give you a desired output. If it's not a desired output, it's just plus 0. So it doesn't matter, or 0 is insignificant. But just in case if it gives you 1, what could you write? It's a b q n bar, correct? So it's going to be a bar b bar q n plus 1, sorry, uh, a bar b bar q n plus 1 a b q n bar. A bar b bar, sorry, a bar b bar not q n plus 1, a bar b bar 1, my bad. So 1 is the output that you're getting regardless. So it's a bar b bar into 1 and a b q n bar. That is what I think is the answer. A bar b bar 1 a b q n bar. So it's a pretty straightforward question. Hmm.
We have writing, but I didn't visualize this question.
You didn't visualize it.
No.
Wait. See, whenever you want to find the expression, just do one thing. You will only find it for whichever output you're getting. You can get one. So for the second and the third one, you're not getting one either way, right? So it makes no sense. Getting it, Manish?
Yeah, yeah, and
So
last.
you can get one only in the first one and the last one, correct?
So we have to write expression for qn plus 1.
You have to write the expression for qn plus 1 in terms of ab and qn bar.
Qn. Qn, na? Qn bar.
I mean ab and qn, it's qn bar over here. So I mean that's why I'm saying it. So qn plus 1 will be what? A bar b bar, because these are zeros. By convention, obviously zeros are bars. So a bar b bar 1 plus ab qn bar. That's it.
In this truth table, we have just A and B, not Qn.
In the truth table, you have a b.
See, Qn plus 1, it depends on D,
Hmm.
and D depends on A, B, and Qn.
Hmm.
So we should have a truth table for A, B, and Qn.
We have a truth table for a b and qn. This is the truth table for a b and qn. I'll tell you why. uh, if a and b are 0,
Hmm.
then you can get one output for sure. Okay, it doesn't matter on qn. Does it matter on qn? Because qn plus 1 is basically giving you 1 regardless. You only have to look for those qn plus 1 which is giving you 1 in the output. That can be the first row, that can be the last row as well, because we don't know what qn bar is, isn't it? It can be 1, it can be 0. So we have to consider that as well. So if you want to do that, the first row will give you a bar b bar into 1,
Uh,
and second row will give you a b qn bar,
bar.
because it depends on qn bar. If it's 0, then the last one becomes 0 entirely. If it's 1, it stays as ab.
Okay.
Is that clear?
Hmm.
Hmm. Always look for the values in qn plus 1 which is giving you some kind of which can give you 1. The first row and the last row has the potential to give you 1. That's the thing. It all looks very complicated and all that, but this is the main thing. Just don't be very confused. It's very straightforward. Okay. One thing. Minimum number of 2 by 1 multiplexers required to design a circuit that implements a function x, y, z. So it's a three expression thing, multiplexer. And sorry, it's a three expression function, three variable function, which has numbers 0 to 6. So how many multiplexers could you need? 2 by 1 multiplexers can handle how many inputs? Manish, tell me.
Multiplexer 2 by 1.
How many inputs can a 2 by 1 multiplexer handle?
Input can be 2, na?
Input can only be 2, right? But you have an expression of 3, correct? Can that be handled by a single multiplexer?
No.
So you need a second multiplexer for that.
Uh,
So if you have two multiplexers, how many inputs can you handle?
4.
No, you cannot handle 4. If it's the same expression, the first input of the second multiplexer is basically the output of the first multiplexer. Na?
Oh, you are giving output to the second, right?
You want a aggregated big one. So for four expressions, if it was f of a, b, c, d, you would have needed two for one for second, one. You would have needed three multiplexers, right, Subhendu sir? That's the thing, right? Yeah, that is the thing. That is the thing. So for three, for XYZ, you need to put in XY as an input of the first multiplexer, and then whatever output comes that feeds into the first input of second, and Z is the second input of the second. So thereby to evaluate this one, you need two by one multiplexers. That should be enough.
Do we have to find the expression of f here?
Expression of
Expression for f here?
no, you don't need it. Unnecessary. Just look at the number of inputs you have, and you don't even need to. I mean, you do need to look at that. Had this only been 0, 1, 2, it would have been handled by one multiplexer itself.
Okay.
So since it is six, six is a three-bit thing, five is a three-bit thing. So you need that second multiplexer to handle this one.
So from left side, it is clear that we have three input.
Left side it is clear. It is three input. But what if I had only 0, 1, 2? Then only one multiplexer would have been enough, right?
Hmm.
So for the to handle 5 and 6, you need two multiplexers. No, sorry, for even four. Four is 1, 0, 0. So 4, 5, 6 needs the second multiplexer, and for the third expression, third position in the Boolean one. It's clear for everyone, right? It's just concepts. I hope it's clear. Chaitanya, Pranam, Sahil, Rajesh, all good, right? Yeah. Okay. All right. Moving to the next one. Okay. A one-bit comparator takes two input bits and outputs one if they are not equal and zero otherwise. What is the minimum number of two input NOT gates required to run? Okay, fine. Let's do it in a different way. Uh, where is it? CST. Okay, let's look at the question once more. Two input bits and outputs one if they are not equal. Okay, so a one bit comparator takes two input bits and outputs one if they're not equal and zero otherwise. Okay, so there are two inputs, IP1, IP2, OP. 0, 0, 0, 1, 1, 0, 1, 1, 1, 1. Okay, now what are they saying? This is the important part over here. Outputs 1 if they are not equal and 0 otherwise. So 0 if they are equal, 1 if they are not equal. So 1 if they're not equal, I think that was it. So this is how the truth table is going to look like, correct?
Yeah, yeah.
So if this is the truth table, what does it look like? I mean, let's try to think of it this way. What gate does it look like?
Like
XOR.
jar of question.
It's a XOR. Yeah. So for XOR, how many gates do you need to build a XOR? How many NOT do you need to build a XOR? How many NOT do you need to build a XOR?
1 minute.
You need 5 NOTs to build a XOR. Those are this is from week 4 or something.
Yeah, this five. Week
Five,
three.
week 3. So just memorize a couple of things like how many for NOR, how many sorry, for XOR, how many NOR you need, how many NAND you need, and for XNOR, for how many NOR you need, how many NAND you need. Just memorize this one at least, just in case if you forget and cannot figure it out. The other way of doing it is taking this as what? This is if I say this is A and B, you would have to just minimize it. That is A bar B plus A B bar, and then you would have to reverse engineer it and try to build it in terms of nod and zor and all that. That's a lot more hard work than if you know what are the total number of gates you need for this one. So 5 is what you need. Just keep it in your mind. Okay, a circuit has four inputs A, B, C, D, and a single output Y. Y is set to logic 1 if A is equal to B and C is equal to D. Otherwise, Y is set to 0. How many max terms present in the POS expression for Y? Okay, so Y is 1 if A equal to B and C equal to D. Okay, so only one condition: A equal to B, C equal to D. Only then Y is 1. Otherwise, Y is 0. So you have four inputs. So just go with your instincts. The first thing you would be tempted to do is create a truth table, right? So let's do that. This is V, this is C, this is D, this is Y. 0 0 0 0 0 0 1 0 0 0 1 0 0 1 0 0 0 1 1 0 1 0 0 0 1 0 1 0 1 1 0 0 1 1 1 1. Okay, I think that's it. Did I mess it up? No, I don't think so. It's just 1 1 1 1 1 1 1 1. Okay. So I hope this is 0 1 0 1 0 1 0 1 0 1 0 1 1 0 0 1 1 1 1 0 1. Okay, fine. I think this looks like it's correct. Let me see if I can zoom in a bit, which is probably not possible. So the condition is A equal to B and C equal to D. That is what will make it true, right? Right, Chaitanya? I guess that was it. Equal to B and C equal to D. Yeah, A equal to B and C equal to D. So check wherein A equal to B and C equal to D and just put 1 there. So for this one, it is true. For this one, it is true. This one, it is true. This one, it is true. Am I missing out on something, or is this enough? I think this is enough. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
That's it. 16 minus 4.
So, so there are 4 ones and 12 zeros. So the question is, how many max terms are present in POS expression of Y? So max terms means what? In this case, if I build the truth table this way, that is the number of zeros over there. Min terms is 1, max terms is 0. So straight away you can see that there are 12 number of ones. Since there are only 12 number of zeros, only 4 ones, so 12 zeros, so 12 max terms. The only thing you need to solve these questions is conceptual clarity. That is enough to get you full marks. So moving on to the next one. This is another one that looks scary and all, but it is not. Consider the circuit of two D flip-flops and one XOR gate as shown below. Initial states are Q10, Q20. What is the number of possible states for the circuit? So what do you need to do? You need to find the next states and see after how many steps you are going to get a cycle. You are going to get a repetition. I think this was 3 or something. Yeah, it's 3. So we can try to build this one. The initial states are. Let me check. Q1 equal to Q2 bar. Wait. Let me open a Word document, try to figure it out if that's possible. Can I try to do it here? Can I paste it here? Arre, 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 arre. This is huge. So, okay, I think this should be fine. So this is the expression. So what do we need? We first need q1 q1 bar, then we need d1. I think, wait, let's go back to that. What is mentioned? q1 is 0, q2 is 0. Okay, so we have to get, I'm not sure if writing q2 here would be safe or we would have to do it again, but fine, let's just go ahead with it. Okay, so what is the expression of d1 and d2? D1 is what? D1 is q2 bar, because q2 bar is going back to d1, right? D1 equal to q2 bar. And what is the expression of d2? D2 is q2 bar XOR q2, I think. q2 bar XOR, technically it is q2, right? Sorry, x naught. Chaitanya, what have you done? q2 bar, x naught, yes, it will be x naught because of the dot. But why are you doing x q1? Okay, yes, that is q1. My bad. My screen is very disappointing, but okay. So q2 equal to q2 x naught q1. Okay, what are the initial states? q1 is 0, q2 is 0. So q1 is 0, q2 is 0. D1 will be what? q2 bar, so that is 1. D2 is what? q2 bar. Achha, what we need, that also we have to write. We need q2. Okay, q2 will figure it out from the next step itself. Fine, we need the next 3 states if I'm not mistaken. These questions need to be done with a lot of precision. Wait, where is it? The initial states of q1, what is the number of possible states? Okay, we need how many possible states are possible. So basically we need to find when we are getting a cycle. So the states would be whatever we are getting the output of the second flip-flop, which is q2. So basically we can track q2 and we'll get it. What is d2? D2 is q2 bar x naught q1. What is q2 bar? Q2 bar is 1. Q2 bar is 1 x naught 0. 1 x naught 0 is what? 1 or 0 is 1. 1 x naught 0 is 0. This will be 0. I think that's the first state. Can somebody confirm? I think that is the first state. But anyway, moving on to the next one. So what is Q1? Q1 is Q2 bar. Q2 bar is 1. Q1 bar is 0. Q2 Q2. Where is Q2? Q2 is D2, so we'll get it later. D1 equal to Q2 bar. How to increase this one?
Actually, you can remove that Q1 bar column. So that is anyway not required.
This is anyway not required. That's what I was thinking. It's getting unnecessarily.
Just remove that column.
Hmm. My screen is completely messed up, so I'm seeing zeros as ones and all that. Wait. All right. So we have to track Q2. Fine. So what was D1? D1 was Q2 bar. What is Q2 now? Q2 was 0. We'll get Q2 by Q1 X 0 D2. Q1 X 0 D2, which is 1 0, which is 1. So this will be 0. What is Q2 bar? This is 0. Sorry, this is 1. What is D1? D1 will be 1. What is D2? D2 is Q2 bar X 0 Q1. So 1 1. What is X 0 between 1 1? That is 1. Okay. So we have the second D2. Okay, next. What is D1? Q2 bar, which is 0. What is wait, DQ1 is 0. Q2 bar, where is Q2 bar? The 0. So what we'll get next, we need D2. D2 is Q2 bar X 0 0, which is 1 0, which is 0. And what is D2? Sorry, why am I even doing D2? D1. All I need is D2, right? Unnecessarily, this is getting confusing. So, yeah. Where were we? So we were at D2. D2 is basically Q1 X 0 Q2 bar. Q1 is what? 0. X 0 Q2 bar, which was 1. So 0 and 1's X 0 is 0 and 1's XOR is 1, X 0 is 0. So this will become 0 again. So what is Q2 now? Q2 now is 0. Q2 bar is 1. Next, what would be Q1? Q1 is Q2 bar. It's getting confusing, I believe. So when sir?
Rahul,
Manish, tell me.
can I share a screen and because I have writing pad, so
Okay. Please share your screen.
you can guide me if I'm wrong somewhere.
Wait, what are they saying in the chat? SP right, Q1 next and Q2 next. Yes, I think Q1 next and Q2 next will make it easier. Manish, share your that thing. Writing pad. Where is this? Please stop this.
Visible ना?
It's visible. It's visible. Yeah.
सबसे पहले is it correct? These two equation for Q1 and Q2.
That is a XNOR gate, no? For D2.
What?
For D2, we have XNOR gate or XOR gate.
I You're not audible.
Yeah, he's not properly audible.
I'm saying for D2, we have XNOR gate now for D2 Q2 bar XNOR Q1.
That is going to be X nor Manish.
Yeah, yeah. Tell me, I will write here.
Okay, I'll tell you the expressions. Q1 is
Q1 n plus 1, no?
hmm, Q1 n plus 1. Yeah, Q1 n plus 1 is basically, let's go back to the diagram, Q2 bar.
Q2 bar.
Hmm.
Q2 n bar.
Q2 n bar. Yeah,
Yeah. Okay.
and where is the next one? Q2
Hmm.
Q2 next is basically Q1 X nor Q2 bar.
Q1.
X nor
Huh?
that is XOR, Manish. X nor is circle, dot within a circle.
Okay. This is
This is X nor. Uh, it's X nor Q2 bar. Yeah.
Q2 bar.
Hmm. Now make the truth tables with columns Q1, Q2.
So I'm starting.
Q1, Q2, D1, D2.
Q1 next, Q2 next.
Q1 next, Q2 next.
Rahul, can we directly start like 0, 0? Then,
We'll do that later. I mean, 00 is given in the question, but just write the columns first. Right, Q1, Q2,
okay, okay.
hmm,
Q1,
Q2,
Q2,
D1,
D1,
D2,
D2,
Q1 next, Q2 next.
Q1 next, Q2 next.
Hmm.
Hmm.
D1 is basically Q1, right, Chaitanya?
D1 is Q1 next. Q1 next is D1.
Q1 next, yeah.
So
So write
Q1 will
those
start.
in front of those expressions as well. In above D1, write Q1 next.
So this is equal to Q1 next.
Hmm. Q1n.
Okay.
And Q2 is, sorry, D2 is Q2 bar.
D2 is
No, that way D1 is Q2 bar and D2 is Q1 XNOR Q2n. But I'm saying that D1, D2 values will be same as Q1 and Q2n.
Hmm.
But anyway, we can start with the initial
Yeah,
state.
let's start with the initial states.
That is
Q1,
0,
Q2 are 00, right?
0, 0, right.
Q1, Q2, Q1 equals 0, 0, 0. Okay, fine. Q1, Q2 are 00.
hmm.
So,
D1 is Q2 bar,
hmm.
that is 1.
So D1 equal to
D1 will be 1 because it's Q2 bar.
uh,
Now D2 is Q1 XNOR Q2 bar. Q2 bar is 1 and Q1 is 0. 1 and 0 XNOR will get 0. Same for Q1 and Q2n 1 0.
Q1n and Q2n are basically D1, D2s.
Yeah,
perfect, no?
So now that you've got Q1 next, so that will be the Q1, Q2 of the next state. So just copy it. Yeah, that's a
So
good one. Write 10 as the next Q1, Q2.
1, 0 as a next, huh?
Hmm. Now what is D1? D1 is Q1.
Q1, huh?
Q2 bar, Q2 bar.
Q2 bar, sorry.
Sorry,
That
Q2
is again no 1. 1 is fine.
Hmm. Uh, what is D2? Wait,
D2 is Q2 bar, which is 1 XNOR
it's
with
not
1, which will give us 1.
1.
Rahul, this is wrong, no?
This is Q2 bar.
This is Q2 bar.
Okay.
D1 is not Q1n. I'm not sure. D1 is Q2 bar and D2 is Q2 bar XOR Q1.
XNOR.
X not Q1.
XNOR
Hmm.
Q1.
Hmm.
Okay.
This is correct. Okay. So coming back, what would be D2? Q2 bar is 0. 0 XNOR 1. 0, 1. Zor is
Q2
1.
bar is 1.
Q2 bar is 1, 1
D2
and
bar is
1.
1. 1 XNOR, it will be 1. D2 should be 1, I think. Okay.
Yeah.
So what will be Q1 and Q2n? It will be 1, 1. Copy.
Okay. Hmm.
D2, Q2 bar is 1, 1 XNOR 1. 1 Zor 1 is 0, 1 XNOR is 1. Okay, fine.
D1
So
is
what is Q1? Q2 bar. D1 will be 0.
D1 is Q2 bar, so 0. Okay.
Q2 bar, which is 0, 0 XNOR 1. 0
0
XNOR
XNOR
1
1.
is 1.
0. 0.
0 XNOR 1 is 0 Zor 1 is 1.
1.
0 XNOR 1 is
0.
0. Right. Will be 0. 0, 0.
So
Q1, Q1 and Q2 and 0, 0.
we've got 3 stages now. 3 states.
Now write 0, 0 in the next line.
Okay.
So you have got the first
Same.
state of Q1, Q2 coming back.
So there are 3 states, right?
There are 3 states confirmed.
Okay. I'm stopping.
Yeah. No. Okay, yeah, fine. You can stop. Let's go back to the questions. With the writing pad, it gets a lot easier.
Yeah.
And you will get one question of this type 100% guaranteed. There are a couple of questions in GA and PA. Just practice that as well. There are 2 more gates or something, I think. Okay, what is the minimum number of flip-flops required to construct a 5-bit Johnson counter, assuming all the basic gates are available? Even I did not know this when I gave the exam, but I just did number of bits minus 1. So please follow suit. So you can 1 minute.
Hybrid Johnson counter.
Hmm. Two by 3, I'm not 500. Okay. Fine.
If it is 5 feet, it should need 5 flip flop, no?
5 states. Why would it need 5 flip-flops? For 5 states, 3 flip-flop is enough.
So shall we write all the states that the 5-bit Johnson counter has
Hmm.
from 0000 to 1000 1100?
Hmm. Basically, n minus 1 works. So regardless of whatever you're doing, just whether it is a Johnson counter or something else. So like we were doing a thing, right, wherein you have a 4 expression, like 4 variable expression. Where is it?
Can we ask Suvendu sir about this question?
Is Shubhendu sir here? He went. Did he come back?
Yes. What happened?
Shubhendu sir, need some clarity on this Johnson counter one. What's the
O-
logic of this?
Okay. So that Johnson counter. So 5-bit Johnson counter. How many will be the unique state?
Hmm. How many Unix states?
I'm getting 10.
I think it will be like not 10. It will be like more than 10.
Hmm.
Can anyone design that?
Manish, can you write?
So if
Johnson
there are
counter
4
can be
bits,
implemented with using n flip-flops to count 2 n distinct states. So 5-bit will have
10 is usable
10
state.
states. Can be
Okay. Okay,
n
10. Yeah, 10 unique state will be there.
hmm,
So what will be the log base 10?
log base 10.
Like ceiling value of log base 10. 3 point something will be
3
there. So
point
you have
something.
to
Two
you
point
have to
seven.
take the ceiling value. That's why 4 is the answer.
Okay.
So did you got like Manish or whoever asked?
Understood the formula, but didn't get what's going inside.
Okay, so the thing is like Suppose you want to design an unique state using the like any flip flop, then you require like log base that n. We have to take ceiling value.
Yeah.
Suppose you want to design 8 unique state. So how many flip flop will require? 3 flip flop will require.
Yeah.
If you want to design like 4 unique state, you will require 2 flip flop, like minimum number. So if you are design like 12 or 30, then 4 unique state, like 4 flip flop is required. So
Okay, sir.
first you have to find the unique state. So 5-bit Johnson counter. So 10 unique state is there. So we require 4 flip flop, like minimum number. We can design more than 4 also.
Okay, sir. Got it.
Okay. Thanks. Rahul, you can proceed.
Yeah, yeah. Okay, so going ahead with this one. Okay, this is another one of those big flip-flop questions. The rest of it are straightforward 3-4 questions. Anyway, consider the circuit diagram given below. Assuming 2 flip-flops are initially cleared to 0, state the output Y for the next clock pulses. So basically you need Q2 for the next 4 clock pulses. Manish, share the screen again. Just write it down if you can.
Okay.
Yeah. Take a screenshot of this image and paste it there, and let's go.
Visible now?
Yes, visible. So write the JK, J1, K1, J2, K2.
Okay. JK.
Now maybe you can start with Q1, Q2, and then J1, K1, J2, K2, Q1.
Wait, any information there? So no, no information is there. Assuming 2 flip-flops are initially cleared to 0, which basically means the outputs are basically 0, I think, right? So
Yeah, so initial state is 0, 0.
0, 0.
Q1, Q2.
Q1, Q2 are 0, 0. Just build the columns first, Manish. Yeah.
Okay. J1.
Okay, we can start from Q1, Q2, then J1, J2.
Right,
So
Q1,
J1,
Q2.
Q1, Q2.
Q2, J1, J2.
J1,
J1.
K1,
J1, K1, J2,
J1, K1, sorry. K1, you should write.
J1, K1.
J2, K2.
J2, K2.
And maybe Q1 next and Q2 next.
Q1 and Q2 n.
Okay.
Now you know what are the initial states of the flip-flop, which are 0. So that means Q1 and Q2 are both zeros. Right? Okay. What else information is given? Assuming 2 flip-flops are initially clear. What? Initially cleared to 0, state the output Y for the next 4 clock pulses. Okay. So J K. K is constant.
Now J is Q2,
Let me
J1 is Q2. You can write it somewhere, maybe left, bottom left. J1 is equal to Q2.
JK. Okay, clock is not going anywhere. Fine. Yeah. J1 is Q2.
J1 is Q2.
Yeah, J1 is Q2. K1 is Q2 bar. Right, Chaitanya?
Yeah. And J2 is Q1 bar,
J2 is Q1 bar.
K2 is Q1.
K2 is
Q1.
Q1.
Okay. Anything else we are missing? Mm,
Oh, we are good to go.
no, I think we're good to go. Yeah. Okay. So what is J1? Q2 0. K1 Q2 bar. Nice. J2 Q1 bar 1. K2 is Q1 0. So what are Q1 next? Q2 next?
J is 0, K is 1, so it will be 0. Reset.
It will be reset. So Q1n is 0. 1 0. 1 0 probably gives you 1, right?
Asset state.
Huh. Okay, over here, Manish, on the left bottom, write the truth table for JK flip flop as well, just for reference.
JK flip flop truth table.
Huh, on the left bottom where you have written J1 K1.
Okay.
Yep.
But no, I forgot it.
No worries. Just write JK 00211. We'll tell you.
JK.
Write
Or
Q.
maybe the excitation table would be better, no?
Huh, excitation table. Yeah.
And Y or the output
Hmm.
or Q, sorry, Q.
Uh, Let me simply copy it from here.
Okay. Okay. That's okay.
It's JK, na?
JK.
JK flip flop. It is better here, I guess. This is enough.
Right.
Yes. Yes.
Okay, Ram.
Okay. Move on. So what was J1 Q2? Just write J1 K1. Q2
Uh,
is 1. J1 is 1.
J1 is 1.
K1 is 0.
Okay.
J2 is 1. And K2 is 0. Okay. Now Q1 next is JK output 1 0. 1 0 is probably 1. Right? Yeah. Right 1. And this is also 1 0. So 1. Okay. Now write 1 1 in the next step of Q1 Q2. Now do J1 is Q2 1.
J1
J,
Q2.
J1 is 1.
So 1.
Q1 is 0.
Uh,
J2 is Q1 bar. So 0 0 1.
J2 is Q1 bar. Okay.
K2 is 1.
K2 is 1.
Hmm. So Q1 next. 1 0 output is 1. 0 1 output is 0. So Q1 Q2 will be 1 0. Wait, is it correct? 0 1 should be 0, I think. Huh, it is correct. Fine. So write 1 0 in the next step. Okay, what was the question? Are we blindly just doing it?
No,
Four,
till 4.
The
four,
output for next 4 blocks.
four steps. Yes, one more we need. Um. Okay, 1 0 is here. J1 is Q2. So it will be 0 1. K1 is 1. J2 is Q1 bar 0 1. And 0 1 will give you 0 0. So next step is 0 0. So basically you're getting four steps before it becomes a cycle. And what do we need? When we need the four steps, we basically need a Q2, I think. Wait, let me check that. Yeah, you basically need Q2. So what are the four Q2s we have got?
1100.
1100. I think that should be the answer. Yeah, that is the answer.
Okay.
Okay, I don't think. Manish,
Mm-hmm.
I'll share the screen, copy these two questions to your notebook. We'll do the two pending one from the PYQ sheet itself, and then we'll solve the two in your notebook itself. Firstly, okay, let's just get it done. If we implement a simple memory array, 8-bit addressability, and address space of 20 bits, then what would be the total size of the memory? So, address space is 20 bits, and addressability is 8-bit. So, you need 8-bit to address individual bits of 20. So basically what do you need? You need 8 into 20 bits in total. So you need 160 bits. This is just simple multiplication. You don't have to go into much complexity. Just simply multiply the addressability with this address space size. That's it. There's an array with 8-bit addressability and the address space of 20 bits. So you need 8 into 20, that's 160. Okay, so these questions, these two questions that we have,
Week 10, 11, 12.
these are new questions, but these are very scoring. You'll get 3-4 questions. Like in this paper itself, they had 4-5 questions, I think, for this. So, hmm, okay, what would be the control word if you intend to perform a register transfer from register Y to register X, right? So you have to transfer from Y to X. So for Y, what are you doing? You're giving output, correct? So this thing will be 1, and register X is what? This is taking input, correct? Rest all the bits will be 0. Manish, do one thing. Take a screenshot of this block itself and copy it to your notebook.
Actually, I have not studied week 10, 11, 12.
Array, you don't need to study. Just solve these 3 questions. You'll be good to go. Exactly. Naveen, that's exactly the thing. Memory, you're not doing anything with the memory. So you're neither reading nor writing. So these will be 0. Register X. What are you doing with X? You're transferring it to X. So X will take an input, correct? This much is it clear, Manish?
Hmm.
If you're transferring information from Y to X, X will take an input, Y will give an output. That's clear, right?
Yeah.
So if X is taking an input, only this input thing will be 1, output will be 0. Okay. So this is 0, 0, 1, 0. And what about the next 4? Y is giving output, no input. So it will be 0, 1. Z is doing nothing, so 0, 0. So what would be the expression? It is 0, 0, 1, 0, 0, 1, 0, 0. So 0, 0, 1, 0 is binary. What is the decimal of that? It is 2. Here, 0, 0, 1, 0 decimal is 2.
So,
And this is what? Y is taking an output. So 0, 1, 0, 0. 0, 1, 0, 0 is basically what? 4.
hmm.
And they always ask in hexadecimal format. They are asking in hex. So 0x something something. So you'll only get 2. So it's 0x24. That's it. Do you think you need to go through the lectures to solve this? I don't think so.
If similar type of question will come.
This question will come 100% guaranteed.
Okay.
So that's the thing. This will come because there's not much in the later weeks, to be honest. So this is the only thing that's going to happen. Okay, this is a very interesting question. Someone posted it on WhatsApp or GSpace, I think, a few days ago.
Week 11.
I'm not sure who that was. Let a processor contain 32 registers in its register file. Consider that an ALU is capable of performing 4 different operations. What is the minimum number of bits required by an instruction in order to perform addition between two operands stored in the register file, then store the result in the register containing the first operand? So you basically have a register. So there are 32 registers. This means assume that there are 32 memory spaces. Correct? Is that much clear? So, and how many operations do you have? You have 4 operations.
4 operations.
And amongst these 32 registers, 32 memory spaces, you have certain numbers, information, some other sort of stuff. You have to do addition, some kind of mathematical operation amongst two of those registers, two of those numbers in those 32 memory spaces. So, which memory space you will access in order to identify? Obviously, you are going to use binaries. How many bits do you need to identify? How will you know? It's 2 to the power n equal to 32. That's the thing, right? In order to represent 32 individual states, how many bits do you need? You need 5.
5. Mm.
That was just clear.
Yes, yes.
So 5 bits to identify the first operand and 5 bits to identify the second operand. Correct?
Yes.
And where will the output be stored? In a third operand? No. They are saying store it in the first operand itself. Store the result in the register containing the first operand. So you don't need any more bits to, um, represent the output register, right? It's just the first register itself.
Okay, okay.
No. So 5 for the first operand, 5 for the second operand. Now, which calculation you need to perform? For that, how will you know? It is 4 different operations. So to choose which operation to do, you only need 2 bits. 2 bits will be able to represent 4 states. So those 4 states will be the 4 operations that you need. Correct? That is clear? Yes, Manish?
Yeah, for
Yeah.
10, 10
So
for,
so how many will it be? 5 for first input, 5 for second input, and 2 for
operator.
operations.
Operator.
It should be 12. It is 12. Okay, no, that one was probably 18. The question that someone else was asking or something. But anyway, for this is only 12. But if they had said that register store the result in a different register, then what should the answer have been? Tell me. If you had to store it in a third register,
So 15, right?
array why 15? What
5,
you
5 for
Another
first.
5. 17 should.
17?
Yeah, yeah. Plus 2 for operator.
Array baba, plus 2. Plus 2 is for 2 is 2 bits only to represent what operation you are doing. If you need a new register, the number of bits required to identify a new register is 5, na? Same as the input, 2 inputs you're taking.
Mm-hmm.
It should have been 17 though.
So your question was ki if you store output in a new space,
In a new space.
so the first operand will take 5 bit,
5 bit, true,
second will take 5 bit,
true, 10,
and result will be stored in a 5 bit.
5 bit, 15. And the
So
operation that you're choosing will take 2.
2.
15 plus 2,
So
17.
that's why I told 15 plus 2, right?
That's why it is 15 plus 2, 17. Yes.
Yeah.
Keep this very clear. Anything can come. I don't know what Shubhendu sir has done. Anything can come. So just keep these concepts clear and please do not be very careful about the words in the question. A little bit of miss here and there can make it not good. Just very clear. These are easy questions just to fetch marks, like, it's literally being given to you like anything. What is the maximum number of registers that can be stored? What is, suppose a control word is this. What is the maximum number of registers that can be stored in the register file? So maximum number of registers that can be stored in the register file. It's all complicated electronics and all that stuff. But basically what it is how many individual numbers or individual inputs can you store in the register file? How will you identify? You can only identify in one way. That's staring right at you. It is the number of bits required to represent one of those. Isn't it? Is that clear, Manish?
Little bit.
Little bit. How much bit? See, there are 5 bits.
Yeah.
Reg X, Reg Y, Reg Z is being represented by 5 bits.
5
So
bits.
how many individual registers you want? 2 to the power 5, right?
Yeah.
You can create 2 to the power individual boxes to store numbers or registers or states or anything. You can get 32 individual pouches to store things. That's the thing. Just that see the number of bits and you get the answer. So that is what it is. Very easy questions these. Now this is where it gets a bit tricky because of these all complications of dr, all that stuff. So for this, I need your help, Manish. Share your screen and copy this question. Let's solve this. Only two questions. You'll be able to solve CSD paper in about an hour. If you have things cleared, you'll be able to solve it in 45 minutes to 1 hour. It should not be very difficult.
I think this last week, like week 10, 11, 12 is from computer organization architecture, right?
Parts of it is related to that because the next step after CSD is operating system. So it somehow, uh, you know, gets on the edge. The most
Basically, CST is like we have designed like to understand the basic understanding of computer science. So to understand the like
computer
computer
architecture.
systems and operating systems,
Hmm.
even networking. So you need to understand about digital and little bit of that computer organization, what we call in the BTech.
Hmm.
So we have combined like two subjects into a one subject. We have designed something like that. So
Hmm. And these types of questions, Shubhendu sir, I also saw in that operating system PYQ in one of the papers. This hex code and all that.
yeah. So basically in OS we are following XV6
Hmm. Hmm.
designed by MIT. So we are reading the code and we are explaining how actually it's like things are happening in your OS.
Yeah. So it's like a level one before operating systems and computer architecture organization and that. So anyway, Manish, copy this, share your screen. Let's do this two questions.
Sure.
Yeah. Okay. This one you have copied, right? Okay, I'll keep the next one ready. Let's go to your thing. Okay, so what are they saying? Manish, read the question and tell us what they are asking to do.
Suppose we want to execute a data movement instruction where we move the data present in register R30 to register R23. Instruction move RD. RD is destination register and RRD is a source register. And operands 0. So D from 0 to
Hmm.
31 and R from 0 to 31.
That's fine. I mean, it doesn't matter anymore. Thing is, what is destination? What is source? Destination is what?
Destination is here 23, R20.
23. Now, beside this question, right? Destination, it's D. Hmm. It is going from 30 to 23. So write S equal to,
S equal to
hmm, and below that write D equal to,
D equal to.
D equal to. These are source and destination. So source is what? 30.
Yeah, source is 30.
Data present in register 30 to, okay, fine. So 30, you need to represent 30 in 5 bits. Why? Because D and R are both between 0 and 31. So
Mhm.
basically 32 individual states, which is 5 bits. Correct?
Yeah,
So write 30 in 5 bits, write 23 in 5 bits. Write them.
30 in 5 bit.
Hmm. What is the 5 bit binary representation of 30?
Okay.
Is 31. 111, right? 111 makes it what? 16, 8, 24 for 28. 10,
Alright. So this
right? 10.
10.
10. So that is 30.
Yeah.
This, the next state is 31, and that is the last one. So this is 30, correct? Confirm it once. It is 30. It is 30. Write D. That is 23. 23 in terms of 5 bits.
5 bit.
Hmm. So 23, you can take 16, Sida. So just write 1 in the first position. So 16 plus 8 is 24. So you cannot take second one, make it 0. Plus 4. Write 1 in the third. That makes it 20.
20.
And then 1, 1. I
23.
think that is 23. Just confirm 16 for 20, 22, 23. Yeah, that is 23. Okay, so now you have made S and D entirely. Now below that, write the instruction format. Write 0010 just
Okay.
below it.
0010
That is already given. The next one is 11
11 DR.
DR. DR, no, no, don't write DR.
Okay.
Just don't write DR. 11, take the first D, take the first R.
So you write 11
1, 1.
11.
And the next will also be 1, 1 because D1 and R1 is also 1. Make S, change S to R. They have mentioned source as R. So change S to R.
So you are saying this one.
S equal to what you have done, make it R equal to.
Okay.
They are saying source as R. Okay, fine. Now, these things that you have, DR, DR, RD, RD, these are just, you have to write them in order. Fine. So first thing you have D and then you have R. So write 1, 1,
11. Yeah. Oh.
1, 1 beside 1, 1. Those are
Again
the
11.
you have written 0, 0, 1, 0, 1, 1, right?
Uh-huh.
After that, write 1, 1. Why? Because the first D is 1, the first R is 1. Now cross them.
Okay.
Now cross them. I mean,
So
strike a line through them to make sure that you're done with them. You won't be confused later.
are you saying
I'm saying काट दो पहला वाला काट दो पहला नंबर काट दो R और D से
ये वाला?
अरे on your right on the green thing
Okay. Okay.
the first number in R and the first number in D cross them out.
This one.
First number in R and D at the top above R equal to D equal to
Oh, are you saying this one?
just cross. Okay, underline them with pink, which is fine.
Uh-huh.
That is also fine.
That is
You've taken one R, you have taken one D, right?
okay. Huh.
Done. So one DR is done. Next is DR, DR, right? So what is
Yeah.
the
DR.
next D? It is 0.
DR. DR. From where you are taking this DR? DR.
Array R equal to we have written 5 bit, D equal to we have written 5 bit.
Mm-hmm.
We have to extract single bits from there.
So okay. Okay.
So DR, DR will be what? 0, 1, 1, 1,
0 1
1, 1.
1 1.
Did you understand why?
So you took first this 0.
With 0, mark again.
Yeah. This 0.
Yes, yes. That's
Then
0.
then this one.
Uh,
Okay. Then you took this one
uh,
and this one.
why? Because DR, DR is given. You have to take the D's and the R's in the sequence they have mentioned. That's it.
Okay. Okay. Got it.
So what
And
should be the next one? It's RD, RD.
RD. So we have to take this one.
Hmm.
So this one and
Hmm.
this one.
Yes. Right.
Again we have RD means this 0
Hmm.
and this one.
Yeah. That's it. Your answer is done. Just convert these hexadecimal to binary. Your answer is done.
Okay. Okay. So we have to convert the last number, no?
Or you have to convert all of them
All of them. Okay.
because it is a 4-bit hex they have written. See, look at the answer. It is 2EB something. They are asking what will be the hexadecimal machine code for the instruction. So you have to take 4 bits at a time. Remember, hexa is 4 bits. Hexa goes from 0 to 15. Remember that?
Yeah.
Yeah.
0 to 15.
So what is 0010? It is 2. Right? 2.
0010.
What is the
Hexadecimal is yours 2.
hexa is 2. 1111 is what?
F.
F, right? 0111 is what?
Uh, First of all, convert it to decimal.
Hmm. What is it?
This is 1. This is 2. This is 4. This is 7.
7. Next. 1101 is what?
This is
Hard water
1, 4,
10,
8,
13.
13.
13 is what in hex?
Uh, A, B, C, D. 1 minute. 0 to 9. A, B, C, D, E, F. This is 13 now. So
Hmm.
10, 11, 12, 13. D now.
D, yes.
Yeah.
So what is the representation? 2F70. That
12.
is what. Yeah.
Correct na ye?
This has to be the correct one. If it is not the correct one, then the answer is wrong.
Check once because in this screenshot it is not visible.
2FBE is written, but that is not correct.
Oh, that is not correct.
No, that is not correct. Shubhendu sir, we had some issues with this question, right? Back in that
I
time.
think we have changed the answer, so you can just explain the process how to do that. That is fine.
This is the way to do it.
I think yeah, 2F70 is the correct answer. What I
I
remember.
also remember I had given 2F70. I was afraid when I saw the answer key. So
Yeah, yeah.
I remember 2F70 is the answer.
Okay.
Naveen, 2F70. Yeah, 2F70 is the answer. Okay, moving on. Now there is another very basic question. Perform a 2's complement subtraction of two numbers 16 and 24. What is the result of?
You are not presenting. Yeah.
I'm not presenting. Wait, I'm
It's
just.
not presenting. You can see, right?
Is it visible now?
Oh yeah.
Okay, fine. All right. So this is one question. This looks a bit tricky, but you have to do it. Thing is, perform 2's complement subtraction of two numbers. A equal to 16, B equal to 24. What is the result of A minus B in 8-bit binary format? What have they given? Note, don't use sign magnitude form. How will you do it? How will you do it? Who will do it? Manish, share the screen again. Take the screenshot and write the binary of these two numbers.
Okay. Can you enlarge it a little bit?
Acha, okay. Better?
Mm-hmm.
Take this. Take the answer as well for reference. There's an easier, less complicated way of doing it, but we'll get to it later. Find the two's complement. How I did it was subtracted 16 minus 21, then two's complement for 8. Exactly. That's the easier way of doing it, Pratanda. Otherwise, the other process is very tedious. Initially, when I was studying this one, I tried to do the lengthy process, but then I discovered this that I can do it either way.
So Rahul, what will be the step? Can you just
Write A and B's.
yes.
Find the two's complement of B. Actually, don't find two's complement of B. Fine. What is 16 minus 24?
Minus 8.
Minus 8. Write the two's complement of 8.
What you said?
Write the two's complement of 8. Two's complement of 8 is what? 1's complement plus 1. I think that was two's complement. Sorry if I've forgotten. Write the 1's complement of 8 first.
So can you just guide me?
Okay, fine. I'll tell you. First, think what is the format they have given. They have given 8-bit.
Yeah.
Okay. So you have to represent this thing in some sort of 8-bit. So what is the 8-bit representation of 8?
So 1 0 0
Ah, okay, fine. Right, right.
4 then 8. So this one is
1 0 0 and you have to give 4 0 before it.
yeah.
Correct? Put it. This is 8-bit representation of 8. Correct?
Mm.
Now, in the next line, just below minus 8, write once 1 apostrophe C.
here.
हाँ उसके just नीचे just write 1 apostrophe c,
Okay.
just to mention that you are finding the ones complement of this.
1, just let me see.
Now write the ones complement of this number. What is ones complement? Just flip the bits, make 0 1, make 1 0. That is ones complement. Okay. Now add 1. Add 1 to this number, you'll get the 2's complement.
So add 1 to this number.
Hmm.
So first convert to the decimal.
अरे नहीं, just add 1 as in add 1 in binary to this.
So 0 0 0, huh?
हाँ 0 0 0 0 0 0 0 1.
Like
Add it.
that. So 1 1 is 0,
Hmm.
and that 1 1 is again 0,
Hmm.
and 1 1 is again 0.
Hmm.
Then we have 1.
Hmm.
Then 1 0 is 1.
Hmm.
1 0 is 1.
Hmm.
This 1 0 is 1. This 1 0 is 1.
Hmm. One more. Yeah. Have you done 8? 1 2 3 4 5 6 7 8. हाँ. That's it. That's the answer. That's the easiest way of doing it.
Yeah.
Just do it the decimal way. It's -8. Just find two's complement of that. That's your answer, because that gives you the sign as well.
Okay.
Okay, that's the trick. Let's see. I think that is it for. That is it for this paper. The only thing you need to be very careful about is that these questions, DRDR questions,
Uh-huh.
you just a little bit of lack of concentration can cost you a lot of marks, and this is very um, scoring. See, there were 3 marks out of the 50 marks paper, and that is 6% of the total. I mean, this is pretty much nothing. Just a little bit of carefulness, and you'll be able to get marks. For this one, you just need to remember what is the easy way to do it, which is just find the decimal difference, and if it is -8, just find that two's complement. If it is plus, then no need to do anything. Okay,
Yeah.
that's the trick for this one. Um, the DRDR will be straightforward. This one is what is the minimum of number of registers after doing all these two what is it called, number of states and all that. I think what is the number of states that it can represent and all that is part of quiz 1 syllabus, I think, or probably early quiz 2. So that is the only thing that is getting carried here. What is the number of registers that can be stored in the register file? So particular register is represented by 5 bits. So like total, how many can you give? 2 to the power number of bits. That is 32. That is straightforward. You just have to apply whatever you know. This one is also very scoring. I need to check where that 18 answer was from. That was probably GA or something. This is also very scoring, not very complicated. Just find that this input output, just this is also very straightforward. Looks very complicated, registers this that blah blah. They need the hex format, which means you need to club 4 bits together, right? So if they needed the what is the 8 one, octal or something, I think octal. If they needed the octal format, then you would have got 4 individual things. Sorry, if it was octal, you would only have got 1, because 8 things you have. They want hex, so you have 4. You have to be careful about what is taking the input and what is taking the output. That is the only trick in this one. So be very careful about seeing it. Same goes for this. I mean, if you mess up this move, source and destination, so the confusing part you can do is the r_r. So just make sure you don't mess that one up. Be very careful about what is your destination, what is your source, and be very careful about whichever binary bits you have already taken as a part of the instruction. So for your convenience, try to cross it out so that you don't mess it up. So that will be.
One question in comment section. I think
Hmm?
one question is in even comment section by Chaitanya.
Can you tell me which one would be after 29 clock? Arey, हाँ, that one. Where is it, yaar, Chaitanya? That's a very good question. What is output after n clock pulses? I think it was in the quiz paper or something. Can you share the link? That's a very fun question. The best part about it, it was a back counter, I think. What is it? Down counter.
Yeah.
It was going reverse. You have to find the states of all that. The very first question. Where are you? Consider a mod 14. Okay. Mod 14 down counter. Initial state is 0000. Right. So it's a 14 counter. A copy. Is it an image? So let's try to do this one. This question might come as well. This is a very classic question. Wait, mod 14 down counter initial 0000. Okay. अरे भाई 000. Okay, 000. Okay, might as well just do it here. Wait, 1 0 1 0 1 0 0 1 0 1 0 0 1 2 3 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14. I think so. These are the 14 states, correct? That's one. Okay, I am starting at 0, right? 0000. Sorry, give me a minute. Let me put in the things. There's only one way of doing it with minimal errors, which is this. Why are you giving me suggestions? Anyway, so this is the first state, correct? So say this is state 0. Now they are asking what is, let's look at this question again. What will be the state of the counter after 29 clock pulses? It is a 14 down counter. So it will count backwards, correct? And initial state is 0. So you need state after 29 clock pulses. So let's go. This is 0. First clock pulse will come where? Here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Where did I go wrong? 14 down counter, so it will have till 13. My bad. Right? It will go from 0 to 13. It will not go till 14. It will have 14 different states, and we are starting with 0000 as well. So this is the state 0. After 1 clock pulse, it will come here. So after say 14 clock pulse, it will come here. Same, it will come here after 28 clock pulses, right? So after 28, it will go back to this. The 29th clock pulse will be here. We'll take the question, the state here.
Okay, so it is given after 29 clock pulse, so the answer is
Is
110.
it after 29 or at 29? What is the state of the counter after 29 clock pulses? Sorry. After 29 clock pulses, it will come here.
Okay, thank you.
24, sorry, wait, 14, 28, 29, this is the 30th. Yes, after 29 clock pulses, it will be here. Anyway, that is also from GA, I think. I'm not sure. What else is there given? The rest of it was fine, right, Chaitanya? I mean, if you've
Ah,
done
those
these kind of questions, you would have more than enough to just go ahead. The only complicated things would be these and this. I think this answer was incorrect, if I'm not wrong. The answer for this was marked incorrect. What else? What else? This is simple minimization. You would have to do it. Obtain the simplified expression in the following terms. And this kind of thing, you just have to look at whatever can give you one. So that's it.
okay.
Just don't do any silly mistakes and you'll be good to get good marks. The later weeks are not very difficult. The only complicated part of it was, at least according to me, it was the states, previous state, current states of the flip-flops and all those complicated D flip-flops, XOR gates, XNOR gates, and all that we were doing previously. So this should be enough. This should be enough to practice. I mean, just do the two PYQs, do your own quizzes, do quiz one, quiz two of the two terms. There's not enough PYQs. So whatever you have, just do it. And that should be more than enough to fetch you good marks. Absolutely, man. Absolutely. Haven't watched it last week. Should I know? Haven't watched what?
I think he did not watch the last week video.
I mean,
Yeah,
lecture video.
I don't know. Yeah, week 12 is fine. There will be like
I think
maybe one
solving
question.
these questions should be enough, Shubhendu sir, isn't it?
Yeah, it will be
This
enough.
should be enough. I mean, even if you haven't watched, I mean, don't start now. There's only 2 days left. Just practice, practice, practice.
Can I ask you two questions? So, which is not related to NTERM.
Okay.
Yes.
Yeah. So, week 11. So you have two GAs, right?
Yes.
Yeah. So one is objective, that is done, and one is subjective.
Yes.
For the subjective, how many marks are there? That is not written in the GA.
I will take average like 50%.
No. So this is one and one. How many marks are there? It's that
So
is not
suppose
very.
week 11 is suppose 100 marks is there.
Hmm.
So we'll take 50% from objective and 50% from subjective.
Okay.
Yeah.
Okay.
It
So
will be like equal weightage.
okay. And
Yeah.
when you're expecting the score, Shubham sir?
Maybe like this week within this week we'll release the score.
Okay. After ET or before?
After it you can
After ET.
calculate. Yeah.
Okay. Okay. And one more question. So for OS, who would be the instructor and TA? The same answer or some
No,
other?
no. Always like professor will be Professor Chester
Huh?
and instructor will be me and Levin.
Okay. And who would be the professor for that?
Professor is Professor Chester Roverio. You can
Okay.
search in
Okay.
Chester.
Okay.
Uh,
Thank you.
yes. So and like instructor will be me and Levin will be the instructor. TA is not decided, so we'll check and we'll let you know.
That will be the second offering, wouldn't it be? Or the
It's
first
third
one?
offering. First
Third
offering,
offering?
like yeah.
Oh,
Yeah.
been a long time then.
Okay. So what is the comment? Oh,
Like,
I'm taking voice from
one
okay.
thing.
Navneet, like this is like XP6 operating system or normal operating system?